Hello, class. Welcome to this quick little lesson. We're going to just go over the 8.2 Part 1 practice problems in case you needed a little guidance. Maybe you just needed me to kind of walk you through some of the problems. Again, you can retake this until you get 100, but if you're still having a tough time, then I would suggest watching this video, seeing and then as I'm going through the problems, we can kind of go over what to do. All right, so let's look at the first question. So the first question is the z-test is used when the sample size is blank 30, or when the population is normally distributed and the population standard deviation is blank. So this is, when you use your z-test. So there are two criteria, right? The first criterion was that you use it when the sample size is greater than 30. Okay, so that was the first criterion, is that n has to be greater than or equal to 30. Okay, so first criterion. The next criterion is that the like if let's say you don't have a sample size that's 30. Let's say you have a sample size that's 25 or 20. Then the alternative is, if you want to use the z-test, then you have to know that the population is normally distributed, and you have to know the population standard deviation. So that means that the second way of using the z-test is that you have to know the population standard deviation. So therefore the answer is greater than or equal to, well, this is not going to be unknown, it's going to be known. So greater than or equal to, and you have to know the standard deviation, the population. All right. So that's from your notes. From number 2, the sample standard deviation can be used to replace the population standard deviation in a z-test as long as the sample size is below 30. So remember that if your sample size is greater than 30, you can use the z-test. Now, if you use your z-test, remember that the formula for the z-test, for the test statistic, is x bar minus mu over sigma over square root of n. Okay, so now if n is greater than or equal to 30, you can go ahead and proceed to use this. However, if you don't know your sigma, that's okay. You can replace sigma with s, as long as your sample size is greater than or equal to 30. Now, if it's less than 30, you should already be knowing your population standard deviation in order to proceed with the z-test. Okay, so if it's less than 30, you can't replace it with s. All right, so here it's saying the sample standard deviation can replace sigma as long as the sample size is below 30. That's incorrect. Has to be greater than or equal to 30. Has to be at least 30 in order for you to use it. Okay, so this is false. All right. So for number 3, from a HealthWeb article, you find a claim that states that the proportion of those in their teens and 20s that tested positive for the coronavirus is 9.3%. You sample 100 individuals randomly, find the proportion to be 8.7%, with a standard deviation of 1.6. You would like to see if this is statistically significant at the 5% level of significance. Assume a normal distribution. So first off, they give you a bunch of information, and they're asking you, can you perform a z-test for a mean? Select all that apply. So you want to perform a z-test, right? Well, we got to look to see what our sample size is. So it says you sample 100 individuals randomly. So our sample size is greater than or equal to 30, right? So since it's greater than or equal to 30, that's a good thing. So that means we can use the z-test. So the sample size is large enough. Now, if the sample size is large enough, this means I can replace sigma with s, right? So we're going to go ahead and replace sigma with s here. If that's what if they give us s. So as it says here, you sample 100 individuals randomly, with a proportion to be 8.7%, standard deviation of 1.6. Now, this standard deviation that they give you is from your sample. So that's S. Okay, so your S here is for number 3. Your S is 1.6, and your p hat, which, you know, we're not even going to be concerned with p hat. Now that we think about it, they do give you s, or they do give you s, they give you n. However, there's one thing that's off about this problem. It's the fact that you're using proportions, right? The z-test is meant for means only, unless you get to the z-test for a proportion. Okay, so if you're talking about a z-test for a mean, which is this lesson that we're doing, then you can only use means, right? But if you're doing the z-test for a proportion, which is going to be the next lesson after we go over part 2 of this, then you have to, then you can't, you know, then you can use proportions. But here, the answer would actually not be yes, because of the fact that we're using proportions, percentages. So therefore, I'm going to go ahead and uncheck this. Even though they give you the sample size is large enough, you're not even dealing with means to begin with. So we're going to say no, because you're not using any means in the study. Okay, so it has to be an average for you to use a z-test for a mean here. Okay. All right. So automatically, oops, let me uncheck that. All right, so that's going to be no. That's it. So in Wisconsin, they administered the WMT to every 10th grader. Random sample of 20 10th graders. So my N is equal to 20 here for number 4. Had a mean score of 310. So the mean score, so from that sample, so that's my sample mean, the governor brags on national TV that Wisconsin has an average of 400 for all of its 10th graders. So this is your claim. So the claim is that the average is equal to 400. So the population average. The standard deviation for Wisconsin's 10th grader is 45. So that's telling you that that's the population standard deviation, okay? Because it's not from the sample, it's just the claim, right? So the population standard deviation is for all the 10th graders. For all the 10th graders, so that's population, it's going to be 45. Assume that the distribution is normal and the 1% level of significance. So we know that alpha is 0.01, and we know that the distribution is normal. Okay, so that's the information that we have. So can we perform a z-test using this information? Well, first off, the n is less than 30, so we can't use the z-test based off of that alone. However, they do tell us that it's normal, so that's good. And we know the population standard deviation. Therefore, we can go ahead and use the z-test. All right, so it says here, yes, due to the shape of the distribution, because it's normal. Yes, the population standard deviation is known. Those two things are why we need to perform a z-test, or why we can. All right, and that's it for that problem. All right, so for number 5, again, the same type, same stuff. So we're going to need the same information. But they want to ask, what is this hypotheses? So what is H0 and HA? Well, we just said that this is our claim, right? So since that's our claim, that means that that's a statement of equality that belongs to the null. Now, it doesn't say whether the researcher thinks it should be greater than or less than, so therefore we'll say not equal to. All right. So therefore, it's going to be mu is equal to for H0, but it's not equal to for HA. So that's the second one, or the first answer choice. All right, now the claim belongs to the, well, we just said that the claim belongs to the null hypothesis. Okay, so since it's a statement of equality. All right, number 7. It says the direction of the test. So what is the direction? Well, remember the direction is based off of the HA. So based off of this not equal to symbol, it's a two-tailed test. Okay, if it's not equal to, it's two-tailed. If it's greater than, right-tailed. If it's less than, left-tailed. All right, in Wisconsin, they administer, same thing. Compute the test statistic. Okay, so we're going to actually go ahead and compute the test statistic. So that's going to be z-test. Okay, so z-test is equal to, remember the formula? So x bar, we said, was the mean score of 310. The mu is the hypothesis mean, which is 400. Sigma is 125 over square root of n. And they did it for how many 10th graders? Sample of 20 10th graders. Okay, so we're going to go ahead and do this on the calculator. I'm going to go ahead and do it. Let's see. Yeah, I'm going to do it on the calculator real quick. Actually, let's go ahead and do it on here. So we got 310 minus 400 is negative 90 divided by that. Okay. So we got about negative 3.22 because they wanted to 2 decimal places. So, all right, just did that there. All right, so there's my test statistic, negative 3.22. I'll write it over here. All right, so for number 9, they said in Wisconsin, they had same problem, the Wisconsin problem, compute the p-value for the Wisconsin problem. Okay, so since we're dealing with z-scores, right? This is my z-score is negative 3.22. Now, so let me show you how to set up the bell curve for this. So since this is a two-tailed test after all, when we do this, since it's two-tailed, this means that you have a negative side and a positive side, like as far as your tails are concerned, right? You have both tails. So since we calculated the z-test to be negative, right? Somewhere over here, remember it goes by negative, it goes by ones each spot, right? So this will be, it goes by ones on each side for the standard. So we got negative 3.22 here and then positive 3.22 there. So you got to put both of them in there when you show your work. So when you show your work, I need you to draw that curve and then label your p-values or label your z-test. So my z-test here is negative 3.22. This is my test statistic here. This is a little bit sloppy here. So this is my test statistic. However, I need to do the positive version as well, okay? Because it's a two-tailed test. If it's a one-tailed test, left or right, you don't have to do that, right? You just have to do the one, label the one z-test. However, since it's two-tailed, do both. And then therefore, you're going to shade both tails. Let's do it in a different color. And then you got to find both areas, okay? So which area would I do? I would use the negative area first, or the area to the left of the negative value, and then I'd double it, okay? So that's what I do. Even if I got a positive answer for my z-test, I will look up the negative value on the z-chart and then double it. That's the easiest way to do it, okay? So our z-test is negative 3.22, and that is negative, so I'm just going to look up that value on the z-table. All right, so I'm going to go ahead and we're going to look up the z-table. Now, just to show you, you can go on the web and literally just type in z-table or normal distribution table, either one. And if you go on, here on images, you can look up various images of the z-chart. And that's if you, if you don't have your z-chart with you, you can go ahead and look it up, all right? They're readily available. So here, we're looking it up for negative 3.22. It's so that means that's going to be 0.0006. Very small. It's you can't see it from your end. 0.0006. All right, so that means that this area is 0.0006, which means that this area has to be the same. So basically you can add them together, or you could just double 0.0006. It's the same thing. So the p-value is adding those together or just doubling it, same thing. And you're going to get 0.0012. That's my p-value, 0.0012. All right. So for number 10, based on the results, what should we do? Reject or fail to reject? Well, we said that remember that if the p-value is less than alpha or equal to alpha, we reject, right? So in this case, the p-value, is it less than or equal to alpha? Well, we said that alpha was 1%, right? So 0.01. That's my alpha that it says there, 1% level of significance. So the number that we just found is clearly less than 0.01, which means we reject, okay? Otherwise, you would fail to reject. So we're going to say reject the null hypothesis. That means we have enough evidence if our p-value is that low. A small p-value is a good thing if you're trying to have enough evidence. So we should conclude that there is enough evidence. So therefore, we have enough evidence since we rejected. Now, the claim belonged to the null hypothesis, which means that we're going to use the word reject instead of support, okay? So we have enough evidence to reject the claim. Now, if the null hypothesis or if the claim belonged to the alternative, we would say there is enough evidence to support, okay? If we fail to reject, you would have to use we do not have enough evidence, right? So that's the key term. If you have enough evidence, that means p-value is small and so on, okay? So just study that in your notes. So enough evidence to reject. All right. So we have another problem here. The average moviegoer sees 8.5 movies a year. That looks like a claim to me. So the claim average is mu is equal to 8.5. Average moviegoer sees 8.5. A researcher thinks this is an underestimate. Okay, so what does that mean? If the researcher thinks it's an underestimate, well, that means that the researcher thinks that's lower than what it should be, right? So that means that the researcher thinks that it should be higher. So since the researcher thinks that's going to be higher, that's telling me that the researcher, which is the research hypothesis, HA, otherwise known as H1. I'll use H1 just to get you used to that. H1 can be used. Mu, the researcher thinks that it's greater than 8.5, okay? And then what does the claim belong to? Well, the claim is a statement of equality, so it clearly belongs to the null hypothesis, okay? So the claim belongs to the null. Okay, now since this is greater than, this is indicating that it's a right-tailed test. That's a right-tailed test. All right, can we perform a z-test for a mean? Well, they said that the sample is 40 moviegoers. So that's greater than 30. So that's good. That means we can use it. So yes, we can use it. And according to this, let's see. Yes, the population, no, let's look at it. Yes, the sample size is large enough, okay? So the sample size is large enough. Now, they tell us that from a sample of 40 moviegoers, the average number seen per person was 9.6. So that's my X bar. My X bar is 9.6. With a standard deviation of 3.2. Now that standard deviation is from the sample, which means it's the sample standard deviation. So you got to use S, not sigma. Now, can we replace S with sigma? The answer is yes, because our sample size is greater than or equal to 30. If that weren't the case, if it's not greater than or equal to 30, you won't be able to replace it, all right, unfortunately, and you won't be able to do the z-test, all right? So therefore, we said yes, the sample size is large enough, but also yes, the sample standard deviation can replace the population standard deviation. Okay, so those are my two answer choices that I'm looking at. All right, so now that we got that information, we can go ahead and do the rest of it. What are the hypotheses? So we said earlier it's going to be equal to, but then greater than. Okay, so that's the first answer choice there. 14, the claim belongs to the, in this case we said the claim belongs to the null. Since the claim belongs to the null, we're in our conclusion, we're going to say there is enough ... evidence. Well, we don't know if there's enough evidence, but there is ... evidence to reject the claim that. Okay, so we're going to use the word reject because it belongs to the null. The average moviegoer, okay, same question. Direction of the test. What's the direction of the test? It's right-tailed. We said that over here. Over there, we said it was a right-tailed test. The average moviegoer, compute the test statistic. Okay, so let's go ahead and do the test statistic. So z-test. We can go ahead, since our sample size is large enough, we can replace sigma with s. So I'm just going to use s there. So I got 9.6 minus, my mu is 8.5, 3.2 over square root of, it says we got 40 moviegoers. All right, so we're going to calculate that real quick. Do it over here on the computer. Right, so we got about 2.1. So the computer or the calculator, the calculator number was 2.174065, but you want to round it to 2 decimals, so 2.17. All right. To compute the p-value. So now, since this is a right-tailed test, you're going to go ahead and show the graph. 2.17 is right. So this is 1, this is 2, this is 3. So this is 2.17. This is my z-test. And since it's a right-tailed test, you're going to shade the area to the right. If it was a left-tailed test, you would shade the area to the left, right? So you're going to be shading to the right. Now, since it's a right-tailed test, and when you look up this value on the z-chart gives you the area to the left. So therefore, you need to subtract from 1 to get the area to the right. Okay? Every time you're doing the area to the right, subtract from 1. So let's go ahead and look this up again, looking it up on the web. We're interested in 2.17. So it's going to be 0.9850. Oops, I didn't mean to minimize that. Okay, so that's the area to the left though, right? So they just gave you that this area is 0.9850. If I want to find the area to the right, I got to do 1 minus. So if I want to find this, which is my p-value, I got to do 1 minus 0.9850, which is going to be 0.0150. So that's my p-value. All right, so now what do we decide? Do we reject or fail to reject? So p-value, is it less than or equal to alpha? Well, alpha is, they said that the alpha is 1%, so which is 0.01. So that's what they said in the problem. Oops, let's go down real quick. So since they said that it was 1% level, that means alpha is 0.01, but we said that the p-value is 0.0150. So this means this is not true, right? 0.015 is actually greater than 0.01. So since 0.015 is actually greater than 0.01, this means we fail to reject. If the p-value is greater than alpha, you're going to fail to reject. So this is actually a fail to reject. Now, since it's failed to reject, that means we do not have enough evidence, okay? So we should conclude that there is not enough evidence to reject. Well, the reason we use reject is because the claim belongs to H0. If the claim belonged to HA, you would use this choice, not enough evidence to support. All right, but here we're doing not enough evidence to reject. All right, guys, that's it for the videos. I was trying to wrap it up, in a relatively short amount of time. But I hope you found this useful, and I'll see you guys in the next one.